Copernicus, The Sun-Centered Answer Part 3. Right idea, incomplete math. Here's what often gets skipped. Copernicus's model wasn't dramatically more accurate than the old one at predicting where a planet would appear. He still believed orbits had to be perfect circles, because that was the ancient ideal for heavenly motion. What he did remove was the equant, the off-center point Ptolemy had used to preserve uniform motion. Many of Copernicus's own contemporaries saw that as his real achievement, because it restored the principle that celestial motion should be truly uniform and circular. But removing the equant meant he had to add his own extra epicycles elsewhere to make the numbers work again. The overall mathematical complexity changed very little. The real problem, that planets actually move in ellipses, not circles, wouldn't be solved for another 66 years. The model did make one striking, testable prediction. If Earth genuinely moves around the Sun, then nearby stars should appear to shift slightly against more distant ones over the course of a year. This effect is called stellar parallax. Copernicus and his contemporaries looked for it and found nothing. His answer was that the stars had to be almost unimaginably far away, so far that the shift was too small to see with the naked eye. That was a real gamble, not a dodge. And it turned out to be correct. Astronomers wouldn't actually measure stellar parallax until 1838. The full picture came together in stages. Each step solved something Copernicus couldn't. Johannes Kepler, working from Tycho Brahe's extraordinarily precise observations, showed in 1609 that planetary orbits are ellipses, not circles. For the first time, heliocentric predictions became genuinely more accurate. In 1610, Galileo turned a telescope toward Jupiter and discovered 4 moons orbiting it, not Earth. It was visible evidence that not everything revolved around a single center. That same year, he watched Venus pass through a complete set of phases, from crescent to nearly full. That could only happen if Venus orbited the Sun. Then, in 1687, Isaac Newton explained why any of it worked at all. One law of gravitation described both a falling apple and an orbiting planet. Copernicus didn't finish the picture. He simply moved the starting point. And from that moment on, everyone else had to look at the universe differently.